to talk about geometric proofs. Okay, that's the 2 columns. So it's going to work just like algebraic proofs, just like the syllogisms we did yesterday. We're going to start with the first hypothesis and end up with, so we start out with, we write our syllogism, then we have the first hypothesis, then we have all the statements, all the other conclusions to get to the bottom, and then the final conclusion. That's the way a proof looks. And then all the statements in between are justified by using definitions and postulates and properties like pros and pos, and theorems, and we haven't really talked about theorems. Theorems are statements that we have to prove. Okay? With definitions, we know they're true. With postulates, remember postulates were duh statements that are like so obvious that of course they're true. Like, duh, they're true. So these we just get to use. We don't really have to prove them. But theorems may be true, may not be true. It's somebody who thought it was a good idea, and so you have to prove them before you're allowed to use them. But once we prove them, we're allowed to use them in every proof for the rest of the year. So what I'm going to do is over on the far side of the board, I'm going to keep a list. As we start proving theorems, I'm going to keep a list of all the theorems we proved so that you can use them in proofs, in other proofs. Okay? It's going to save us time because remember, once we prove this hypothesis and this conclusion, we're allowed to skip the middle. We can just go straight to the conclusion. All right? So let's just switch. Remember a little bit about the wording. You know, instead of the hypothesis and the conclusion in proofs, we call them the given and the proof. So in this statement, I skipped all the middle sentences. So the syllogism isn't there. This is just the first hypothesis, the last conclusion. So I went ahead and pulled out the conclusion we were allowed to take from the syllogism. So even though the syllogism isn't there, that's the first and last statement. All right, so in a proof, the original hypothesis is the given. So in this one, what's the given? Exactly. 2 angles are a linear pair. Okay, this statement up here. And then what are we trying to get to? What's the final proof statement going to be? Yeah, they are supplementary.
You guys don't know what the abbreviations mean, then don't write it in your notes unless you know what they mean. Okay? That symbol means angle. So if you don't know that that means angle, write out the word angle. Or lin pair, if you don't know that that means linear pair, write out the whole word linear pair. Because if you don't know what it means when you write it down, you're not going to know when you go back and look over your notes.
Okay, how about the next one? What's the given? AJ, what's the given for this one? Yeah, 2 angles are complementary to the same angle. Okay, and the proof then would be, Rebecca? Equal. Yep. Right, they're equal. So after you get done, like I said, I didn't give you the whole syllogism. I just gave you the beginning and the ending. I gave you the final conclusion you're allowed to draw. But they become in proof language, they become the given and the proof. Yep.
Okay, so is the if basically the given and then it's the...
Exactly. Exactly. Okay? Now, when we do a proof, if I just say they are a linear pair or just 2 angles are a linear pair, it's really hard to prove because we can't do any math with them. We don't have any specific stuff to put our hands on. So instead of saying they are a linear pair, I draw a picture and name two angles that actually are a linear pair. And then I have something concrete to work with. And it doesn't really matter. Like my picture could look like this. Isn't that a linear pair? Okay? Or I could draw it like that. Would that be a linear pair? Yeah? How about if I drew it like this? Would that be a linear pair? Yeah. So it doesn't really matter how I draw it. I just need to draw and label my two angles as a linear pair. So my given, instead of saying two angles are a linear pair, I'm going to say angle 1 and angle 2 are a linear pair. So it just makes it more specific. But do you see how it's kind of the same statement? Okay. Okay? Same thing with my proof. Instead of saying they are supplementary, I'm going to say angle 1 and angle 2 are supplementary. But then once I prove that they're true for angle 1 and angle 2, doesn't it work for any linear pair? It doesn't really matter what, because I could draw it any way I want. It would still work. Right? And then the plan would be the syllogism, the statements. Like, so I could say, if 1 and 2 are a linear pair, then their outside rays make a straight line. And if those outside rays make a straight line, then that's a straight angle, right? So it equals 180. And if it equals 180, then if it makes a straight angle and 1 and 2 make up that angle, then that 1 and 2 equal 180. So I could make up a plan. I could write all my syllogisms. But to save time for today, what I did was I wrote all the statements and all the reasons here. So all we have to do is like grab them and put them in the right place. So let's put the ones we know for sure in the right place. What do we always start with? The given. And when in our case, what's the given? Yeah, angle 1 and 2 are linear pairs. Up here?
It's the third one.
Yep, there you go. Angle 1 and 2 are linear pair. Why is that? Given. I think that's down at the bottom. Yep. Okay? And ordinarily you wouldn't be able to do this, but since I gave you all the possibles, what goes here? What's always the last statement? If the given is first, what's always last?
Just like on your homework last night. What did you always fill that last box with? The proof.
The proof. So I know that angle 1 and angle 2 are supplementary. There we go. Thank you. That's going to go there. Now, I don't know the reason yet because I don't know how we're going to get from here to here. So I can't fill that in. But I know that all those things are going to have to be in the place. The given and the proof. We always start with the given and with the proof. Now I have to figure out how to get there. Okay? So if I think back, remember the definition of a linear pair are two adjacent angles whose outside rays make a line. Okay, and all I know is that I have a linear pair. What could I say here? Which of those statements am I allowed to say based on only the fact I know it's a linear pair?
Can we maybe separate some so we put like the reasons in one side and the examples on another side?
Sure.
You guys know which ones would be? Do you understand the difference in what would be a reason and what would be a?
Yeah, let's do that together. So, reason or statement? Statement. Reason or statement? Substitution of code? Reason. BA and BC form a statement. Angle 1 plus angle 2? Statement. Addition, angle addition postulate. Definition of a linear pair. Angle statement. Definition definition of supplementary angles? Definition of straight angle?
Okay. Does everybody understand how we got those two categories? No?
All right, so what can we say based on the fact that we know that it's a linear pair? Which one of these can go there? Anastasia?
Measure angle 1 plus angle 2 equals angle ABC.
Not quite yet.
Do you know why you can't choose that yet? No. Okay. Because have we mentioned anything about angle ABC yet?
Not yet.
The only thing we've talked about is angle 1 and angle 2 are a linear pair.
So that's what makes proof hard, is you're not, even though you know that's true, you got to wait until you can prove it. So yes?
Measure angle 1 plus measure angle 2 equals 180.
That's what she just said. We can't, oh no, she said ABC. But we can't yet, even though I know you know that's true, we haven't said anything up here yet to prove that yet. So we got to go, all we know is that 1 and 2 are linear pair. So think back to the definition. The only things we're allowed to say is that they're adjacent and that their outside rays make a straight line. So what would that be? Line or ray, right. Ray BA and ray BC form a line. And we base that on the definition of a linear pair. Okay? So now we know not only that angle 1 and 2 are a linear pair, but that BA and BC form a line. So if they form a line, what can we say about that line? Which of these statements?
So we have 3 reasons left to give, right? And one of the reasons talks about angle ABC, and the other 2 talk about something being equal to 180. So which one of those can you automatically eliminate? That's not the next step. The one with angle ABC.
This one?
Right.
Mm-hmm.
So then we're left with measured angle ABC equals 180, or angle 1 plus angle 2 equals 180.
Remember, we just said we formed a straight line. What's another word for a straight line? Straight angle. What's a straight angle equal? 180. So which of these do you think it is? The last one?
Look at I think it looks helpful. Can you pull the picture up?
Oh, yeah. So we have angle 1 and angle 2. Yeah. If we know they form a line and we know that's a straight angle, isn't this the definition? Isn't this a straight angle? This is the straight angle, and we know it's equal to 180 because all straight angles are equal to 180. It's the definition. Okay. So now we want to start talking about angle 1 and angle 2 again. So how are we going to combine this angle we just created with angle 1 and angle 2? Can't get everything on the same. Put these here and these up here. That way I can get everything on the same screen. How am I going to combine, because I've been talking about angle ABC, now I want to pull in that angle 1 and angle 2 again. So how could which of these 2 statements combines angle ABC with 1 and 2? The first one, right. It says angle 1 plus angle 2 equals the whole angle. Part plus part is whole. Which of these reasons tells me that part plus part equals whole? James? The angle addition postulate, right. The angle addition postulate says part plus part equals whole. All right, so obviously then we can say angle 1 plus angle 2 equals 180. And why would that be? Because remember, look, the only thing that changed is we took out ABC and replaced it with 180. Substitution, right. Okay, and then if 1 plus 2 equals 180, then they're supplementary, right? Isn't that the definition of supplementary angles? 2 angles you add together to get 180. for the next one, I already wrote the proof. I want you to give the reason. Turn that on. So, why won't that work? Let me put this down. Definition of complementary. And think about definitions are biconditional, right? So I'm allowed to read them either way. So I can say, since they're complementary, then they equal 90. And I can say, since they equal 90, then they're complementary. You can use a definition, right? Either way, the converse or the conditional. So I can use that as a reason whether I'm going from the fact that they're complementary to the fact that they equal 90, or from the equal 90 to the fact that they're complementary. I can use it going either way. Okay?